Welcome back to Calbeckistan, a place where anybody can learn math. I'm Mr. Calbeck, and today we're going to be talking about finding equations of lines. And we're going to go through the sequence that you're probably going to see in your typical math classroom. So we're going to just jump right in here. Okay, there are three levels of difficulty in finding the equation of a line. And we're going to start with the easiest case. The easiest case is if they have given you a slope and a y-intercept. All right, so I'm just going to write those up here. And we're going to see how that changes. So slope and a y-intercept, all that means is they might say, hey, student, your slope equals 4 and your y-intercept is equal to -3. All right, that's probably what your problem looks like in your textbook. And this is a super easy problem to solve if you remember the basic form of a linear equation, and that's y equals mx plus b. Now, you probably learned that from middle school on. It's a really common equation. And the cool thing about this kind of problem is that y equals mx plus b, the m stands for the slope, and the b stands for the y-intercept. So if you are given already the slope and the y-intercept, you can literally just plug it right into the equation. You don't have to do any math other than to recognize that the slope goes for the m and the y-intercept goes for the b. This is such an easy kind of question that you're probably not going to see many questions like this on quizzes and tests, because it's just kind of a duh question. Do you know the very, very basics? So the answer to this one would be, well, the slope is 4, so I'm going to replace m with that. And the y-intercept is -3, so I'm going to replace b with that. So it would look like this. Y equals 4x. And then it would be plus a -3. But if you ever see plus a minus in a problem, it's redundant. We don't need to add a negative. We can just write -3. Okay, so there's your answer. And that's all the more complicated it gets. And because it's so easy, I'm not going to spend a ton of my time on it either. If you see a question like this on the test, you just go, ka-ching, free points, because that's what your teacher gave you. All right, so that's the easiest level of finding an equation of a line. The next most challenging area, if we do that, the next most challenging level is if they give you a slope and a point. And now this gets a little bit more challenging, okay? So we have, right here, they've hidden some things from you. Okay, you can still use y equals mx plus b in this problem. The problem is, I didn't give you all the information. You're going to have to find some of it. And there's a number of ways you can go about solving a problem like this. So let me give you an example of what this might look like. And I'm going to give you a couple of ways to solve it and see which one that you happen to like the best. So if I gave you a slope, it would probably be something like this. Maybe the slope is equal to 2. All right? And then I'm going to give you a point. You are supposed to find the equation of the line that goes through the point 4, 1 and has a slope of 2. That's what we're shooting for here. So you can try this a number of different ways, but if you ever get stuck on a graphing or on a problem like this, try to graph it. It's a great fallback. You can use your intuition on what would happen here. So let's just graph this and see if that helps us solve the problem. All right? So I can graph it, and hopefully you would have graph paper so it'd look a little bit neater and you could be a little more accurate. But you can do this without graph paper if you're careful. And that's what we're going to shoot for today. 4, 1 is right here. That's the x and the y right there. So the x-axis and the y-axis are right here. So my point is right there. Now if I know the slope, I can actually work backward to try to find the y-intercept. Because remember, the y-intercept is simply the place the line crosses the y-axis. So if I remember that the slope is really a fraction here, 2 over 1. Don't forget that every slope is a fraction, whether it's given to you that way or not. The slope is simply the change in y over the change in x. Some math teachers talk about rise over run. By the way, this triangle is a delta. It's a Greek letter, and it just means the change in. So if I have delta y or triangle y, that means the change in y over the change in x. But that means I'm going to go up to and over 1 if I want to graph this. Now, I always graph left to right. If I want to graph the y-intercept, I actually have to go the other direction. So I'm going to go down 2 and over 1. And I'm going to keep doing that until I hit the y-intercept. Down 2 over 1, down 2 over 1, and down 2 over 1. And I get down here. You can connect all these if you want to. But you can actually work backward if you're careful. You work backward and find the y-intercept. So let's see what this would be. -1, -2, -3, -4, -5, -6, and -7. So my equation would be the slope, which was given to me, -7. That's one strategy to solve this problem. Let's try this problem without graphing. Okay? Let's pretend that we don't know anything about this. All right, I don't know the equation. All I know is the slope and the point. So if I try to plug this into my equation, all I've got here is 2x and then this mystery number b. Okay? And this is a problem if you've done math problems. You know that you can only solve for one variable with one equation. If I have 3 variables, I actually need 3 equations, which is kind of horrible. So there's got to be a better way to do this. And really the problem here is, I know b is really what I'm looking for. So if I just find a way to plug in a number for x and y, then maybe I could solve for b.
Yes, Mr. Calbeck. Yes, I think you have an x and a y already. You see, up there, the 4 and the 1, don't you see? You already wrote x and y under there. Yeah, it's there.
Thank you, Mr. Annoying Math Student. But you're right. I do have an x and a y. It's right here. The 4 is an x, and the y is a 1. Okay, every coordinate that you ever have is simply an x and a y number. So if your equation is using x and y, you can plug these in for x and y, and it will be a solution or an answer to your equation. So I'm going to do that here. I'm going to replace the x with a 4, the 4 from the coordinate right here, and I'm going to replace the y with a 1. And I can just solve for b now. And this is actually a pretty easy equation. Most of you probably learned this in 6th grade. And again, this isn't my answer. Some people are really tempted to just get b and circle it, but I didn't ask you to find the y-intercept. I asked you to find the equation. So make sure once you find the equation that you actually plug it back in for b. Sorry, -7. Okay? And do your math teacher a favor and box your answers. Makes everything a lot nicer for us. The last, most difficult kind are 2 points. Okay? So you have this progression. Super easy, medium, and this is more difficult. I wouldn't call it hard, but then I'm a math teacher, so I'm not sure that I'm the best person to ask here. And hopefully, when we're done with today, it won't be hard for you either. All right, so let's look at a couple of examples here. Your teacher might give you something like this. Two points, and they're going to ask you to write the equation of the line through them. Like last time, a great strategy is to graph it. You can go ahead and plot these points somewhere. So if you were to plot them, you have -3, 5, and you don't have to necessarily be super accurate on this, but it would be helpful if you have graph paper. and then you've got 2, -10. So I'm just going to go ahead and plug some of these numbers in, plot my points here. It's never a bad idea to sketch your graph, because if you do that, you're going to be able to check your work. I can tell a lot of things by graphing these 2 points. And the first is that my slope is negative. Whatever I end up with, I should have a negative slope. And the second thing that I'm going to be able to tell is that the y-intercept is probably negative. Okay, so once you do find a y-intercept, you can check it by graphing and see if it matches up with your graph. If it doesn't match your graph, you probably made a mistake and you need to check your work. All right, so the first most difficult thing is you don't have either piece. You don't have anything. Okay? All you have is 2 points. So we're going to have to find both the slope and the y-intercept. The easier of those two is to find the slope. Now remember, the slope is the change in y over the change in x. Remember, rise over run, change in y over change in x. If you graph this, you can see the slope pretty easily. Your teachers probably taught you to draw a slope triangle, which simply means to see how far your line is going to go down between these 2 points and how far it's going to go over between these 2 points. And we can take a look at this, and you can kind of count. It's not actually that hard to do. I have +5 to -10. If you look at that, you see that's a difference of 15. And because it's going down, I'm going to say that that's negative. With the x's, I'm moving from -3 to +2, and you can see that that is a difference of 5. Now if we go back to our definition of slope, remember slope is change in y over change in x. The change in y was simply -15. The change in x was +5. So now I have a fraction here. And this particular fraction reduces really nicely. -15 divided by +5 gives you -3. So my slope for this one would be -3. And I can find that by graphing it. So I can already plug in part of my equation. Erase this for a second. Now, some of you may have noticed something about this. Oh, I see another hand out there. Excuse me.
Mr. Calbeck! Hi again. Why don't we just do the same thing? We've got an x and a y. Plug them in.
Yes, math student, you're absolutely right. This does look exactly like the last kind of problem we had, where you have the slope, you don't have the y-intercept, but you're given 2 points. Your points are x and y. The cool thing is, you can pick either point to plug this in and do the same algebra we did before. It doesn't matter which point you pick. The only important thing is to not mix and match. Don't pick an x from this one and a y from this one. You have to pick both variables from the same coordinate, or you get the wrong answer. So I'm going to pick whichever one I think looks a little bit easier to me. These numbers look smaller, so I'm just going to pick those. Again, my y is 5. My x is -3. And I can plug those in and solve for b. And we're going to see if that matches up with what we had on our graph here. So that's going to give me a +9 here, because -3 times -3 is +9. And if I want to solve for b, I simply subtract 9 from both sides, and I end up with -4, which looks really close to what I would have here based on my rough sketch of the graph. So that looks like a pretty good answer. Again, this isn't the answer. I want to plug it in to my equation right here. Now, I wanted to mention there are other ways to find slope. You don't have to graph it if you don't like graphing or you're not very good at it. There are other ways to do it. The way that most math teachers will teach you, actually is my least favorite method. It's the slope formula. The slope formula looks like this, if you want to copy it down for your notes. That's the slope formula right there. Some of you might be wondering what the heck these little numbers are. Those are called subscripts. So this is, we say this is y2 minus y1. It's not y squared. It's different. This just means the second y minus the first y. And the second x minus the first x. Now from my experience, many students mess this up royally. They put the wrong places, the wrong numbers in the wrong places and that kind of thing. But if you're accurate and you're careful with your negatives, you can get the right answer. So what I'm going to do here, I'm going to plug in my x's and my y's. And a great idea, if you are going to use the slope formula, is to name your points. So if I've got the x and y under here, I'm going to name this as x1 and y1. Notice those numbers are together in the same coordinate. And I'll name this one x2, y2. Once you name them, you simply plug them into the equation. So the y2 is negative 10. The y1 is 5, so it's negative 10 minus 5 over x2, which is 2, minus a negative 3. And if you simplify this fraction, you'll have the same slope that we found by graphing. The issue that most students have with this is you're not careful about your negatives. The subtraction is in the equation, so that doesn't go away even if your number is negative. Be careful with that. So if we simplify this, negative 10 minus 5 is negative 15. 2 minus a negative 3, that's the same as 2 plus 3 is positive 5. Negative 15 divided by positive 5 is negative 3. Now, for some of you who love formulas, if you're careful plugging this in, it's a great way to find your slope. Otherwise, it can be very dangerous. So I wouldn't just try to randomly plug stuff in. Graphing is a safer method to get it right if you are not perfect with your negatives. Okay? There's actually one other way that's my personal favorite way to find slope, and that's to make a table. All right, so we're going to make a table here. You can plot these points in a table. So x and y, you can do this. So I would say x is negative 3, y is 5, x is 2, y is negative 10. And when you're finding slope from a table, it's really easy. It's a lot like graphing, but you don't actually have to draw any pictures. Remember, the slope is the change in y over the change in x. So let's see if we can find the change in each one. How far did I have to go from positive 5 to negative 10? I went down 10 units. Sorry, I went down 15 units. Change in x, I went from negative 3 to positive 2. That's a plus 5. All right? And now I've got my change in y and change in x. I think this is the easiest method if you like your tables. I think it's a great one. So again, we have the same story we did before. Negative 15 over 5, which is negative 3. Now, whichever of these three methods you like, use it. Okay? Some math teachers try to force you into one way of doing math, but that's simply not how math works. There's lots of correct ways of doing math. And it would encourage you to do whichever one makes the most sense to you. Whichever is the most intuitive, whichever you feel like you're getting the answers right the most commonly. So don't let anyone force you into one way of doing math if your brain naturally tends towards another way. Okay? That was our equation there. I'm going to give you a challenge question. See if you can do this. I'm going to tell you right now, there's going to be a fraction involved, so try not to scream and run away. But try to apply what we've been doing here, and I'll see if you can do it. Here are your points. Again, I'm going to go ahead and erase this. Points 4, 6, and 6, 9. So go ahead and try this on your own. Hit pause and see if you can get it. All right, let's see how you did. I've gone ahead and put these into a table because I think that's the easiest way. And we're going to find the slope first. Remember, we're trying to plug in m and b into this equation. So I'm going to find my slope, which is going to be change in y over change in x. The change in y is 3. The The change in x is 2. So my slope is going to be 3 over 2. And I'm going to plug that right in to my equation. Now, we just need to find an x and a y so we can solve for b. You can use either one of these points. I'm going to choose the one that's a little bit smaller here. We'll see if that helps us. So I'm going to plug in y, which is 6, and x, which is 4. And I'm going to try to solve this one. Okay, if I want to simplify this, I've got a fraction, so I need to put this over 1 so I can multiply them together. Remember from 4th grade, when you're multiplying fractions, you multiply straight across. So I end up with 3 times 4, which is 12, 2 times 1, which is 2, and that's going to reduce to, you guessed it, 6. So I end up with 6 equals 6 plus b. And you can subtract 6 from both sides, and you actually end up with 0. Don't be afraid if you get 0 as an answer for variables. 0 is a number just like 1 and 5 and everything else. And so I'm going to plug this into my equation. And you see here, if I get plus 0, you don't really need to write that down. You can leave it as 0, or you can just erase it altogether, because adding 0 doesn't actually change anything. All right, great job. All right, we're going to look at one more problem, one more challenge problem. This one's going to be a little bit tougher, more fractions. All right, I want you to see if you can find the equation of a line through this one. Again, more fractions, try not to get scared, but it won't be too bad, I don't think. Again, I've plugged it into a table for you, so we can find the slope really easily. 3 and 7 makes this a y change of plus 4. This is going to be a change of plus 3. So my slope is going to be 3 over 4. So when I plug this in, I'm going to have y equals 4 over 3, change in y by change in x, plus b. All right, and we're going to go ahead and see if we can solve this. I'm going to choose a number. I'm going to choose this second equation to plug in. Remember, this is an x and a y. So I can plug 2 in for x, 7 in for y. I'm choosing that one because I don't have any negatives. I like to do things with positives if at all possible. So we're going to go ahead and plug that in, see if we can deal with all these ugly fractions that go with it. All right, so 7 is equal to 4/3. And I'm replacing x with a 2, and I'm going to make it 2 over 1 so I can multiply that more easily. 4 times 2 is 6. Or sorry, Calbeck strikes. 4 times 2 is 8 over 3 plus b. And I just got to solve for b. And I get this fraction here. Notice I didn't change it to a mixed number. Mixed numbers are great if you are in 4th and 5th grade. You're in high school now. You guys can deal with improper fractions. And they generally make things easier if you leave them that way. Okay, so 8/3. I'm going to subtract 8/3 from both sides. Again, fractions are just numbers, so try not to freak out if you see this. So you can see 7 minus 8/3. Again, we're going to go back to 4th grade math and see if we can remember how to subtract fractions. I'm going to rewrite this as 7 minus 8/3. Remember, if you are adding or subtracting fractions, you need a common denominator. To find a common denominator here between 1 and 3, I'm going to multiply the top and bottom by 3. So 3 times 7 is 21 minus 8. When you subtract fractions, you just subtract the numerators, not the denominators. So 21 minus 8 is positive 13 over 3. This doesn't reduce, it's equal to b. So I can plug that right back into my equation over here. And this is going to be 13/3. Just leave it like that. Again, don't feel the need to switch that to a mixed number or fraction or a mixed number or decimal. Decimals are way uglier and less accurate. They take much longer to do the math on too, by the way. So leave it as a fraction, and that's good. All right, I'm going to show you one more way of doing this problem. This is something a lot of teachers don't even teach in Algebra 1. but you guys are so awesome, I'm going to teach it to you. And the way that we do this is much easier than what we just did with the fractions. You'll find that some of you might love this method, some of you might hate it. I just want you to see it. Okay? It's called point-slope form. Turns out y equals mx plus b isn't the only way of writing a linear equation. In your class, you've probably seen linear equations written in this form. This is called standard form, which is really useful when you're writing equations out of a situation. Word problems work really well in this. But there is another form that a lot of people never even tell you exists, which is called point-slope form. I'm going to show you what that looks like. It looks ugly at first, but try not to panic because it's going to make this problem a lot easier. It looks like this. Y minus y1, which looks suspiciously like the slope formula, but it's not, equals m times x minus x1. All right, and this looks super ugly, but it's really cool. What point-slope form does is really similar to the y equals mx plus b, except for one thing. Y equals mx plus b is called slope-intercept form. It's called slope-intercept because it takes a slope and an intercept, the y-intercept to be specific, all right, which is just one specific point. The y-intercept happens when x is equal to 0. So it works really well if you have a coordinate with x being 0. But in this case, I don't have that. Neither of those is 0. You saw the ugly fractions show up. So this is a great method if you have a situation like this. Okay? So we're not going to use slope-intercept here. We're going to try point-slope form. Now notice I still have an m here. It still means slope. So if you need to write this in your notes, you can. It's a slope. Okay? The y and the x are actually the same thing they meant in y equals mx plus b. They're variables, they change, and they can take on any value. But y1 and x1 are actually different. This is a specific y coordinate. And this is a specific x coordinate. Now you can maybe see right away why this would be easier. You don't have to work backward and find the y-intercept because you've already been given 2 points. Okay, so here's how this is, sorry, if that's not clear, let me show you what I mean. We found the m in the same way. You're going to have to do that no matter what you do. Again, I think the table is a great method, but the slope is going to be something you're going to have to calculate no matter what you do. So in this problem, it ends up being 4/3 if you use your table like we just did. And some of you are sitting there saying, Mr. Calbeck, this actually looks harder. Now I have to find 4 things instead of 3 things. But you've already been given everything that you need. Y1 and x1 are simply specific y and x coordinates, which you've already been given up here. All you need to do to finish point-slope form is to plug in your x coordinate and your y coordinate. You don't have to work backward and find the b term. So what I would do here is I would say, well, y is equal to 7, so it goes in like this. X is equal to 2, so I'm going to plug it in like this. And that's it. You don't have to solve anything. You don't have to do any math. You just need to find the slope and plug in a point, and you're done. I would encourage you to be careful with this, because notice there's a subtraction in both of these. So negative coordinates will appear positive in your equation. Positive coordinates will appear negative. So be aware of that as we go on. Let's try one, see if you can do this on your own. I'm going to give you a set of points. I want you to see if you can find the point-slope equation of them. All right, hopefully you've tried this, and I imagine if you tried to find this the other way, that you would hate this. All right, we can find our points here. I'm going to put this one first because it's a lower x number. And I'm going to find my slope, which is going to be -1 to 9 is +10. And this is 3. So your slope is 10/3. That'd be pretty ugly to work with if you had to work backward and find b, but the point slope form, it's super easy. Remember, it's y minus y1 equals m times x minus x1. We just found m, so I'm going to plug that in here. I'm going to replace the m with it, just 10/3. Again, don't change that to a mixed number. Now I'm going to plug in a point. I'm going to choose 4, -1. You could choose either one that you want. Remember, that's an x and a y. So my x is 4. I just replace the x1 with a 4. That's all I have to do. Y becomes a -1. Notice the negative, or the subtraction sign in the point slope equation is still there. So if I take a -1, it becomes a +1. And I hope that you would write that out correctly like that. And that's it. So hopefully you enjoyed this lesson. I will include practice if anybody's interested in trying some of these. I hope you guys have a great day.